Okay, everybody. What we want to do today is we want to find our goal is to find percent of change. And we also call this our percent increase or decrease. So when you think about percent increase and decrease, you can think about how many different types of applications there are real world-wise. You can talk about money prices, you can talk about anything that has to do with values. So great thing is you've solved a lot of proportional equations. This doesn't necessarily have to be proportional. So the way that we're going to solve a percent of change is you are going to find the absolute value of the difference of both values. So you're just going to subtract the two, and that's going to be over the original amount. So obviously when you look at the two numbers, if your numbers go down, it's going to be a percent decrease. If your numbers go up, it's going to be a percent increase. So let's start with an easy example. Let's say that to start with, the temperature was 40 degrees, and we go to 97 degrees. So the first thing that we know is we know that the original was 40. So we're going to find the absolute value of the difference. And the cool thing is, since we're talking about using a calculator, you can do it any way you want. I mean, we could do this, 40 minus 97, divide it by 40, because 40 was the original amount. Your absolute value, and so we're talking about 40 minus 97 is going to be negative 57 over 40. You and I know that we're talking about 57 over 40. So if we divide 57 divided by 40, we get, they're not all going to be this long also, guys, 1.425. So that's our decimal amount. So we want to convert that into a percent, which means we're going to convert it 2 times, multiply it by 100. And we're going to want to round these to the nearest whole percent. So this one is 143%. So think about it. We went from 40 to 97, so it's 143% increase. So let's say that you have a shirt that you want to buy. The shirt is $85, but you're buying this shirt because it's on sale. So you go from $85 down to $60. That means your original amount is 85. So we're talking about the absolute value of 85 minus 60 divided by 85. Absolute value of 25 over 85. So if you go 25 divided by 85, you're going to get 0.294. And so if we want to round that to the nearest percent, 29.4, and nearest whole percent, 29%. Now since it went down, remember that's a 29% decrease. Okay? I'm going to give you a little head start on this one. As you can tell, the math is incredibly complicated. You totally have this one. So let's say to start with, we're at 47, and we go to 63. So I want to know the percent increase or decrease. We're talking about the absolute value, 47 minus 63 over 47. absolute value of negative 16. 16 divided by 47. So if we do 16 and we divide it by 47, we get 0.340. We want to go ahead and make that a 34%. Since we went from 47 to 63, it's a 34% increase. Let's try one more of those. So this is our percent of change, percent increase, decrease. So let's say we go from 91 to 36. And our original is 91. So we want the absolute value of our difference. So 91 minus 36. 55 over 91. Divide the two. And we get 0.604. Move it 2 times. 60.4. We end up at 60%. And since we went down, it's a 60% decrease. Alright, so we have one other goal that we want to do with this. As you can tell, they're pretty straightforward in terms of how we solve it. And these are simpler also. What we want to do is we want to solve for our percent error. So sometimes it's kind of important to know how far off your actual answer is. So in terms of similarities, what we're going to do is we're going to find the absolute value difference of our two numbers. So I'm going to give you two different numbers that we thought were close, and then the difference on this one is we're going to divide those by the actual number. So you want to think about, in this case, which one was the real number that it was. So think about it this way. Let's say you opened up your sock drawer and you thought that there would be 49 socks in the drawer. But it turns out that there were actually 65 socks in the drawer. So our percent of error is the difference in the two over the actual, and remember in this case we said the actual number of socks was 65. So if we find the difference between our two socks, we end up with negative 16 over 65, which means our difference technically is 16 over 65. Divide those, and we end up with 0.246. So that means we actually made a 25% error. Okay, let's do the same thing. Let's say that you looked in a bag and you thought that there were 12 apples in the bag. It turns out there were actually 73 apples in the bag. Hey man, what can I say? You're not very good at judging apples. So absolute value of the two of them over the actual number, which in this case is 73. And so we end up with negative 61 absolute value. 61 divided by 73. You end up with 835, 2 places, so you made an 84% error. I think probably your career of being able to tell apples in a bag is over. Alright, last one. Let's say that you look in a room and your estimate is that there are 37 people in the room. In actuality, there are 8 people in the room. let's just say your estimation skills really, really need some work. So your actual is 8. So we want the absolute value of the two of those. So we end up with 29 divided by 8. So 29 divided by 8 is going to give us 3.625. 2 places. So if we round it, you have a 363% of error. Okay, so what have we learned here? You're not good with apples, you're not good with people in a room, but you are tremendous at math. All right, great job. Great job. I'm going to give you one more to try. Let's say that, okay, I'm going to give you one last chance to redeem yourself. So you estimate that you have 18 pencils in your bag. Turns out you were super close. There's actually 29 pencils in your bag. So, actual number is 29. Absolute value. So you end up with 11 over 29. So you're going to divide both of them. So if we divide 11 by 29, you get 0.379. So you made a 38% error, which, considering that your last error was 363%, you're on the right track. Okay, good luck.